Hello everyone. For question 29, we're given a graph, and you want to be careful here because this isn't the graph of this equation. These are two separate things. So I'm just going to label this. This is f of x, and g of x is an equation down there. So it says f of x is the graph there, and g of x is this equation down below. Which one has a larger maximum value? And we want to justify our answer. So in other words, this phrase right here just means we can't just say g of x and circle it. They're not going to award us any points for guessing here. They want us to show our work. So keep in mind, with parabolas, we have one of two things happen. Parabolas can either have what's called a minimum value. That's if it's concave up. The parabola looks like this. Or our other option, if it's concave down, if it's downward facing. If it's concave up, smiley face, it has a minimum value at some point. In other words, the graph has a point where it reaches its lowest. Versus if it's downward facing, it has what's called a maximum value. This is the highest the graph will ever reach. What do both of these points have in common? They are both the vertex. So no matter what, the vertex is always going to be a minimum or a maximum value, depending what the graph looks like. And remember, this is when a is positive. It's happy, smiley face. This is when a is negative, sad face. Some negative value. I put -1, any negative value. So now let's go over to f of x. So basically we want to find the maximum value. And just visually with the graph, it's very easy. The maximum value we could see, this turning point right here, it is at, let's count, 1, 2, 3, 4, 5, 6, and the x-coordinate's 1. So for f of x, it has a vertex, I'm just going to call it v, of 1, 6. So what's the maximum value there? What's the y value? It has a max of 6. The highest this graph gets vertically is 6. Okay, g of x is going to be a little bit more difficult. What we can do, we can use a formula to find the vertex. That formula is -b over 2a. That's going to tell us the x value, and then we can evaluate that to find the y value. So -b over 2a is going to give us -4 times 2 times -1/2. Just going to write 0.5. Okay, and that's going to be 2 times -0.5 is -1. So -4 over -1. Our vertex is going to occur when x equals 4. Now we can plug in 4, or we can simply use our graphing calculator to help us here. So I'm going to type in g of x. I'm just going to write, again, 0.5. 0.5 is the same as 1/2. Oops, x squared. That would be helpful. And that would also be helpful if I put it in the right spot. Let's start over. There we go. -0.5 x squared plus 4x plus 3. Always make sure you type it in. You don't make any errors like I just almost did. And now we're going to go to our table. And I'm looking when x is 4. And let's just double check that we see some symmetry here, that it is correctly our vertex. We see when x is 4, we see 11, and then notice the values on either side, how they're kind of descending in the same order. 9, 9, 6.5, 6.5. So 4, 11 is correctly our vertex. So for g of x, there's a vertex of 4, 11. Now what's the actual maximum value here? We said earlier the maximum is the y value that goes along with that vertex. So here the maximum value is 11. So now that we know both maximum values, which one has the larger max, we can say g of x. Not the graph, but the equation we were given, g of x. And the reason being, You could write it out in words. G of x has a max of 11. Anything like that, comparing it to f of x. So we'll say g of x has a max of 11. Just as long, when they say justify, even if you just have your work there, that's enough justification. But we'll just close it off here. You don't want to just guess and put one or the other. That's worth no points, even if you guess correctly. Has a max of 11. And f of x only had a maximum of 6. Only had a max of 6. And obviously we know 11 is greater than 6. Okay, so that closes out that question. Very important that we showed our work and that we justified all of our results. Thank you for watching.